Okay, right. Thanks for reminding me, Peter. We're recording. All right. So I'd like to just make one comment. I think in all the years that humans have been looking at the sky through telescopes, nobody's ever seen a mouse arrow wandering around the sky. So I've got my doubts. I've got my doubts that we're a computer simulation. Can I suggest that we have a quick look at Sabine Hossenfelder's take on this? I think that might be helpful. Anybody else got comments on what we have seen so far?
Derek, I have 9 questions here.
Okay, go for it.
There is just too much to ask. There are too many questions. I have never seen such a provocative presentation. And I cannot go through all of these because, I mean, we'll be here all night and other people have got questions to ask as well. But I think one of the main questions are the fine tuning he was talking about at the end there. The fine tuning of the real rules of our universe defines the fact that we are here in this space, in this time. And he mentions multiverses, other universes with different
constants,
rules.
Yeah.
And I would imagine in other universes, I would imagine beings totally different from ourselves, probably not even visible to us.
Okay, but the problem is, remember what he said, they've been doing simulations of universes on supercomputers and changing the rules slightly here and there, changing the parameters, changing the constants. And what they find is that if the rules and constants are different to what we experience in our universe, then the universe wouldn't exist, essentially, and life wouldn't exist. He did say there were very, very few exceptions where they might. So yeah, he didn't go into a lot of detail there, but that to me, it's always been quite staggering, actually, that everything there are so many, there's a multitude of factors, all of which in our universe have to be in place. Otherwise, our universe wouldn't exist. It's not just one thing, it's hundreds of things which need to be in place as they are, to the precision that they are, or our universe wouldn't exist as we know it.
But that's exactly the point I'm trying to make. I'm not doing it very well, but I'm trying to make is the point that our universe would not exist. But another universe would likely exist with totally different rules. We cannot make the rules for the existence of other universes. We can only observe the rules for our universe.
Well, we can test them based on logic, and all we can use is the same logic that we have. You know, in another universe, 1 + 1 will also be 2. It won't be 3. So you can look at the numbers, look at the measurements, look at the constants, look at the physics things, and adjust the constants slightly, and you still got to logically link them. When you put in different rules and different numbers, you still got to look at how the logic affects the various things. How would gravity be affected if gravity was different, and so on, as he was saying. If gravity was different, then things would form differently and the universe wouldn't exist. So you can't just say, oh, with different rules, a different universe would exist. Those rules would still have to mesh with each other. So you look at you throw the whole set of rules into a computer, and you look what would be the outcome if you make all those rules affect each other. What would you end up with? And you end up with 0. A lot of the time, anyway. according to him, occasionally you do actually get a universe. So that's the whole point of what he's saying. It's beyond miraculous actually that our universe exists with all the correct parameters for us to be able to exist. All right.
Yeah.
Go ahead,
Derek.
Go ahead, Anne.
Yeah, I was just thinking, I think what Peter means, I might be wrong, but I think what he means is we can only observe and measure that which we know. So there might be all kinds of things that we can't measure because we don't even know they exist. So is that what you mean, Peter?
Yeah, I think that's what he means. But I think we can only work on logic. We can only use logic to analyze things. And if the logic shows that it can't exist, then it can't exist. Not in our world, anyway. So yeah, that's the only way we can assess things. So if you say, if you just to try and keep things simpler, just change one parameter at a time. So let's just say keep everything the same, but just make gravity slightly different. And just making gravity slightly stronger or slightly weaker precludes the existence of our universe. So that's just, and then you take one thing at a time. Of those 100 constants, take any one and change it slightly, and you get the same effect. So in the end, what we need is all those constants have to be in place as they are for our universe to exist as we know.
So do you think there is a God who said, these are the rules, those are the numbers, 1 over 137 is the number, in spite of the fact that our numerical system is human constructed?
No, I don't think it's human constructed, it's human observed. So if we see one apple and then we see another apple, then we give that the name two apples. You could give it any other name, but it wouldn't change the fact that it's 2 apples. So it's not human constructed, it's human observed and human labeled.
Yes, but when you get beyond the number 9, then it becomes human constructed, doesn't it?
No. You could have a different number system, and then you don't
could.
need the
Like
9. You can have the number ix. You can have you can have a 2 to the power of something, which would equal 9 in the geodecimal system, or decimal system. Sorry, not geodecimal. So yeah, it's just labels, but it's the same. It's labels for the same thing. Different labels doesn't make it different. So I think we should. Anybody else got more comments and questions? Peter, you had a whole list, you say. Give us another one. Or are they all linked to your first question, really?
Yeah. He talked about lifeless and sterile. Yeah, quite so. It would be lifeless and sterile. But again, it comes to the same thing. It comes to the same question at the beginning. It depends upon the rules as we observe them. That's just my opinion. I may be totally wrong. I hope I am.
Yeah, I think that, I think we need to ask the right questions with anything, get insights. So yeah, I think maybe the question we need to ask is, what is the smallest amount of different things which you could start a universe with? What is the smallest number of parameters? What is the smallest number of objects? And with those, you then create a universe. So we seem to have come down to quarks and electrons. So I don't know, maybe all the quarks are actually the same, but just with slightly different properties. They're just one quark with slightly different properties. Maybe what the quark is made of, maybe it's just a number facing 2 different ways. So maybe you can get back to a binary system. All you need is a something existing or something not existing in a space. Then you end up coming back to a binary computer program, being the universe. Yeah, which is quite interesting. But I just have a question. If the universe is a computer simulation, then you need to be able to literally define each quark in every proton, in every atom, and every electron in every atom in the whole universe. You need to describe it. So how do you describe that? What do you need? What hardware do you need to describe that? You need to have let's say, a transistor which can describe a different transistor for each parameter of the quark. So say a quark has got 4 parameters and that's all. So then you need 4 transistors to describe one quark. So to describe every quark in the universe, you need 4 transistors, and there isn't that amount of matter in the universe. So it's impossible for the universe to be a computer program. That's my view. Unless, of course, our observable universe is a very tiny fraction of what there is. Then it's different.
Yeah. Derek, just one more little thing. We were watching a lecture on superconductivity.
Yes.
And this guy from, I've forgotten which university he's from, but anyway, he could express every single constant relating to magnetism and electricity in terms of the speed of light. He reduced them all to expressions, every constant, using the speed of light, the charge in an electron, and Planck's constant, different permutations of those 3 values. It was kind of fascinating. If everyone's interested, I could forward it.
Yes, that sounds very fascinating. If you could forward that to us, please. I think forward it to Peter. He knows who was attending, and you can just forward it as one of the things to everybody. Fantastic. All right. Shall we have a look at Hossenfelder and see what she has to say, or anybody else? There's still a hand up, David and Elaine, or was that for them previous? All right. I'm sure you've got a lot to say.
No, I'm quite in awe. I'm quite in awe of all this wonderful exposure.
Okay. All right. I think we should have a quick look at, I'm going to pause the recording and then start. Sabine Hossenfelder's, I think it's about 10 minutes. It's not too long. Everybody's okay with that? Okay. And we're back. All right. She got a bit complex there for a while. Didn't really give one sort of, but I think overall the view is it's just an unscientific assumption to say that we're living in a simulation. So that's essentially what it boils down to. All right, everybody's still muted. Peter, did that give you any indication there of, well, Elaine?
Yeah, I
No,
must
Peter?
say that, look, I held the floor too long on the last one, but just one very quick comment. You're likely to be simulated, she said. I just wonder, a simulation of what? Because if you're simulated, you have to be a simulator of what? Because I remember working on simulators as a pilot, and the simulator simulated an aeroplane. So I didn't quite get her point about the simulation of what are we? Like, for example, she showed that thing, that choice that we get, are you a human being? And you were supposed to choose who in that selection of pictures was a conscious being, and it depends upon what you define as conscious. I mean, if they put a picture of a mouse in there, would that be selected as conscious? Many people would say no, and others would say yes, and most would
Absolutely,
probably
yes.
say we don't know.
Absolutely, yes. Mouse is a sentient being, as far as I'm concerned. And even I would go so far as to say that there was a fruit on a chair or something, an apple or something. In one of I would say that's a conscious being, because scientists have proven that plants can feel pain and communicate pain. So yes, I would say even plants are conscious.
And is an AI, is that a conscious being?
Well, conscious being, I suppose AI starts to become a bit of a gray area, because what AI does is it takes information and draws conclusion and produces, you know, AI right now can write computer programs from scratch to do something. You can do that now with ChatGPT.
Yeah.
So, you know, all right, but it can't feel emotion. That's one thing it can't do, I think. So yeah. All right, I think then at the other end of the scale also, we don't want to make the evening too long. The whole thing of the 1/37, sort of what it is and what it means and what we think it is and where it comes from is also just a fascinating topic on itself. And there's a short video on that, if I may show that as well. Anybody, first of all, anybody else want to comment on Sabine's views? And sorry, I'm just stopping with something else running simultaneously on the internet, and it's ruining my bandwidth. Anybody else want to comment on the last video? Okay, can we show the one-on-one on that fine structure constant, because I think that's actually very, very interesting as well.
Please excuse me, I've got to get started on supper before.
Okay, I'm going to, if anybody wants to watch this, I'm going to start it. Yeah, I'm just going to find it quickly. Here we go.
Thank you to Squarespace for supporting PBS. It's the job of physicists to worry about numbers, but there's one number that physicists have stressed about more than any other, and that number is 0.00729735256 ... approximately 1/137. This is the
Okay, who liked that one? I thought it was great. This fine structure constant. This is actually what I was saying at 1.2. The universe started with one number. What he was saying at the end, everything else revolves around that number.
Has anyone looked at it in relation to the Fibonacci code? The basis or
Fibonacci,
Okay.
that's just a ratio which comes up in nature sometimes, I think.
well, it comes up in music, it comes up in art.
Yeah,
1.37 is just a number.
yeah, it's like a logical progression. Yeah. So, yeah, maybe you can do us a talk on that, on the Fibonacci number, Nick. How about that? You do it. You do the next study group or cosmology. Tell us all about it.
I
Go
only
on,
know the mystery.
All right.
Yeah, go on, Mick.
You've voted yourself in there, Mick. Okay. All right. Peter, you're back. You had supper already.
Yeah, I'm just about to shut down. I've got to get back to the stove there, otherwise I'm going to burn everything.
Yeah. Okay, I'm going to send everybody the links to these 3 videos just in case they haven't got them, in case somebody wants to look
Derek,
at
and
it.
I'll watch that last one.
And then
definitely.
I've got transcripts of the 2, the one on this 137 and the main one. I'll send out the
Okay,
transcripts as well. You can forward
Thanks a
those
lot,
to
Derek.
everybody, you know. Okay. All right.
Yeah,
Thanks,
just-
everybody. Oh, go ahead.
Yeah, Derek, just you choose fantastic subjects. Just thank you very much.
Yeah.
Thank you.
Thought-provoking.
Lovely.
Yes,
Yeah,
that was
I
fun.
never realized there was something like this fine structure constant until I came across it about a year ago. It was the first time I'd heard of it. Nobody really
Well,
seems
we
to talk
came
about it much, but I think it's
No,
extremely
but that's the
important.
first time we've heard of it tonight. 1/137. Interesting. Thank you, Derek.
Yeah, 1/137.0359999 actually.
Sorry about that.
And
Hi,
Derek,
Derek.
I always thought that the square root of 3 was such a special number.
That's an imaginary number, isn't it? Or what do you call it?
Well, I
Or
can't
square
remember.
root
but
of
it was
2.
special. But I also remember during science, whenever one couldn't equate things or make equations work, you would just put in a constant. And that way we thought any scientist could become famous because we had to learn all these constants at school. But tonight's
Yeah.
constant was definitely different.
Yeah, that one's got no units and it appears everywhere. So its name is the fine structure constant. Nobody could claim it. It's not Planck, it's not Boltzmann, it's not anything else.
Derek?
I'm glad Mick didn't mention Nostradamus' constant. I thought Fibonacci was going in that direction.
Oh yeah, I was afraid of that myself.
Thanks.
Derek?
Sorry, go ahead, Laura.
Remember that John Saunders did talk on the Fibonacci numbers. I think it was for one of the Science Week
Okay.
presentations. But
Yeah, maybe I must actually, because it is quite fascinating. It is comes up in nature in the structure of things a lot. And maybe we could find one as to why that should be. It could be very interesting. I'll look for something.
Right.
All right. Thanks everybody for attending. I don't know if you want to get back before the load shedding happens in 5 minutes. I'm okay. I've got batteries.
Yeah.
Right.
The chap at
Thank
Phillips Kopp, who's a botanist mainly, I think he's very good on the Fibonacci code. Maybe he's worth presenting it. He's a very interesting presenter. I'm not sure.
All right. Do you want to give him a call and ask him if he can do something, even if we do it in a study group thing?
Yeah, I don't know him to call, but I'll try somebody who might. I think someone in the world of botany would be able to get him to have the chat. I don't know how its relation to astronomy or cosmology works, but
yeah, I'll look to see what I can find astronomy-wise, but it's quite fascinating, you know, in the natural world how it appears everywhere. So yeah, I mean, like the length of your fingers and the way the human body develops, it's all according to the sequence in many of the ways.
Yeah, as I say, music,
Animals, plants, everything in nature.
Yeah, and the black notes, the semitones are the 5, and then the black notes are the 8. So it's all in that code as well to get all your musical. Yeah.
All right, thanks everybody. I'm going to stop the recording now. Otherwise, you'll never come back again.
Good night, everyone.
All right.